Okay, problem 14. It tells us that there are one-way routes connecting these towns, and the distances in kilometers are marked on each route. So traveling along these routes, what is the shortest distance from A to Z in kilometers? So recall that there are some existing problems that ask you on a grid of like dots and points that have distances between them. How far, like what's the minimum distance from at like the start to the end? So this is the same logic, except it moves it onto a graph that is irregular and has different distances across each of the nodes. So what you would do in this problem is you would find the shortest distance from here to here, and then so on for each of these until you can finally calculate onto the final ending node. So we do the same thing here as we find the shortest distance to each of the nodes within this graph. So the shortest distance to A would be 0, and to X would be 5, since there's only one path to X. And next for M, you can consider that there are two paths here. Either one is through 5 and 2, and one is through 8. So clearly the shortest path here would be 7. Next, you can go either from X or M to Y. And so from X, if you go from X, the path length would be 15. If you go from M, it would be 13. So we know the shortest path to Y is 13. And you do the same thing with C. Either you can go from 14 or you can go from 5. So the final shortest length is 18. And you can do the same again for the final Z. And you get 30 on top and then 28 here, or 32. So the final shortest distance would be 28. So you get the answer A, and you're able to do it relatively quickly.